A very pleasant evening to one and all present here. I take immense pleasure in welcoming everyone to our webinar on wireless transmitter and receiver using RF module presented by Mr. Farooq Junaid FJ. Let us now invoke the blessings of the Almighty for the successful conduction of the program. With the blessings of our founder chairman, late Shri D. Sudarshanam, let us go for the commencement of the program on behalf of SA Engineering College, an autonomous institution, Dharma Naidu Educational and Charitable Trust, Board of Trustees, our respected college chairman, Shri D. Duraisamy, Secretary, Shri D. Dasarathan, Correspondent, Shri S. Amarnath, Director, Shri D. Sabarinath, our beloved Principal, Vice Principal, heads of all UG and PG departments, professors and faculty members, and student delegates from schools and various colleges. Let me take the pleasure of sharing some information about our institution. SA Engineering College was established by Dharma Naidu Educational and Charitable Trust in the year 1998-1999 with the overall experience of 23 years of teaching excellence till now. It is an autonomous institution affiliated to Anna University, Chennai and approved by AICTE Delhi. The college is well equipped with 5 lakh square feet of constructed area, which includes classrooms, drawing halls, laboratories, and associated facilities. In recognition of the high quality policies, our college has been awarded ISO 9001-2015 certification. All of the undergraduate programs are accredited by National Board of Accreditation (NBA), Delhi, and NAAC certified with A grade. The college offers 10 UG programs and 6 PG programs. The college maintains high standards of education by providing a wide array of world-class academic facilities, employing highly qualified and experienced faculty members, and creating an ambience of conducive college education. Once again, I welcome every one of you for joining with us. Now I hand over the session to our resource person.
For your maintenance of wireless transmitter and receiver using RF module. I hope now everyone could able to see my screen. Okay, today's section is about wireless transmitter and a receiver using RF module. RF module. RF is nothing but radio frequency. Send data from transmitter to receiver wirelessly. The frequency range varies between 30 kHz to 300 GHz. RF signal that are modulated using ASK, FSK based on type of the module. So if you see the full form of RF is radio frequency, where the data will be transmitted and received in wirelessly. And there are many type of RF model which with different type of uh, frequency band. Mostly it will be 30 kilohertz to 300 gigahertz. And basic principle of send the data and receive is ASK, FSK like that. Main function of an RF module. Act as a transmitter of a signal, a solution for detecting radio signals, bridging communication between two devices. RF can stretch communication between applications, act as receiver module. Type of an RF modules. 433 MHz RF transmitter and receiver. XB module, 3-pin RF module. And as I said, there are many type of RF module, but these three RF module are mostly used in that 433 MHz RF transmitter and receiver is used in many places. In this section, we are going to discuss only about 433 MHz RF transmitter and receiver. What is RF 433 MHz transceiver? In the word transceiver, if the transmitter and receiver, if working means in a place means it we used to call as a transceiver. So RF 433 MHz unit or a 433 MHz radio modules are modules which can communicate using the 433 MHz frequency band. It works like any wireless system. And system using these modules is composed of transmitter and a receiver. So, as I say, it's a transmitter and a receiver which is used to send the data in wirelessly. But in this, the frequency band is 433 megahertz. So this is how our 433 megahertz RF transmitter and receiver looks like. The small embedded system, no, it is a transmitter. This big one is a receiver. If you see, we have pins like ground, data input, VCC, antenna. Ground, data, it's no connection, VCC, ground, core, and antenna. Well, the ground file used to be grounded. Sorry, the ground used to be grounded. This is the data input where the serial data used to be sent into this pin, and this is VCC pin where the power supply is given to it, and the antenna is connected to this pin. This is called antenna pin. Like in the RF receiver, we can see ground. So ground, it is a data output. Okay, after the transmitter send signals. I mean, sorry, it send data to the receiver. The data used to come out from this pin only, and it's no connection. VCC are for a power supply, and it's ground and a antenna. Antenna for to connect with the antenna. Required components: breadboard, PCB dot board, RF transmitter and RF receiver, which is 433 RF encoder IC HT12E, RF decoder IC HT12D, push buttons, LEDs, ohm resistor, which is 750K, 33K, and connecting wires. Well, you can say, well, the breadboard and PCB dot boards circuit construction are transmitter and RF receiver, which is for transmit and receive the data. We using a encoding, which IC is IC HT12E for encoding. We using decoding IC HT12D for decoding. Push buttons for give the inputs. LEDs to indicate the output. And ohm resistor we are using because we are going to enable one oscillator in the IC. So we are using 750K and 33K and connecting wires. RF transmitter and receiver, which is 433 MHz. The RF module is a combination of RF transmitter and RF receiver. The transmitter receiver pair operate at a frequency of 433 MHz. RF transmitter receives serial data and transmit it wirelessly through its RF antenna. RF receiver receives the transmitted data and it is operated at the same frequency at that of the transmitter. It is done using 433 MHz radio frequency signal that are modulated using amplitude shifting ASK modulation technique. In order to implement a wireless transmitter and receiver, we use encoder IC HT12E and decoder IC HT12D. Well, if you can't able to understand this, in the upcoming slide, I will explain it very clearly. Don't worry. So, component description. Transmitter module. The transmitter module consists of pins namely VCC, data input, antenna, and ground. The VCC pin has a wide range input voltage from 3 volt to 12 volt. Transmit consumes a minimum current of 9 milliampere and can go as high as 40 milliampere during a transmission. A data pin to transmit the signal. The signal module using the ASK and then send out at a frequency of 433 MHz. Receiver module. RF receiver module has pin namely VCC, data output, no connection, antenna, and ground. A VCC pin should be powered with a regulated 5 volt supply. The operating current of this module is less than 5.5 milliampere. The signal is then modulated to get the data and sent out through the data pin. So before I go to the next topic, I would like to say about no, we should know about the serial data and parallel data. If in case of serial data, you can see one transmitter and one receiver. In the serial data, in the transmitter receiver, there will be only one channel. Okay, only one channel will be there. The data will be transmitted from a transmitter to receiver in one channel, but in a serial way. See, 0, 1, 1, 0. It will go in a serial way in only one channel. It's called serial data. Parallel data, there will be a transmitter and a receiver, but in this case, there are many channels. See here, I have think 1, 2, 3, 4. It's 4 channels. Right? The parallel data, there will be many channels, multiple channels. We can say, where the data will be go into one by one. So, each channel, one data will go 0, 1, 1, 0. In each channel, the data will go in. Encoding and decoding using ICs. So I said about encoding and decoding. IC HT12E for encoding. For decoding, IC HT12D. If you take about IC HT12E, where the parallel data, I used to tell the parallel data and serial data, right? Those parallel data are converted into serial data using encoding IC HT12E, 12D. So sorry, 12E. Similarly, but in the decoding IC HT12D, the serial data is used to be converted to parallel data. Where decoding operations are happening here. I told about serial data and parallel data over here. ASK, amplitude shift keying. For sending the digital data over radio, this module uses a technique called amplitude shift keying ASK. It amplitude shifting the amplitude, that is the level of carrier wave. In our case, it is a 433 MHz signal. It is changed in response to the incoming data signal. This is very similar to the analog technique of the amplitude module, which we familiar with if you are familiar with the AM radio. It is sometimes called a binary amplitude shift keying because there are only two levels we are connecting with, depending of it on or off switch. For digital one, the drives the carrier at the full step. For digital, the cuts the carrier off completely. This is how amplitude module is looks like modulation. So here is this is called as a square wave. Okay, digital data square wave. Whenever there is no square, I mean it's not up, it's down. And whenever it is down, there will be no signal will be come out. Whenever it is one, it's a 0 and it is 1. When it's a 1, and there will be scalar signal will come out. This is called an amplitude shift keying. Where this only the data is transmitter. RF encoder IC HD12E. IC is an encoder IC that converts the 4-bit parallel data from the 4-bit pin 4 data pin into serial data in order to transmit over RF link using transmitter. So if you see, we used to give the data, okay, 1, 2, 3, for the 4 parallel data we used to give. Those parallel data are encoded and come out as a serial data in the pin number 70. Data input is given in 10, 11, 12, and 13. In case of RF decoder IC HD12D, it is a decoder IC that converts the serial data received by the RF receiver into 4-bit parallel data and drives the LEDs accordingly. You know about decoding, which converts a parallel data to serial data. Okay, the parallel data. Sorry. Decoding IC is about converting the serial data into parallel data. Where the serial data is come from the receiver, it go into the data code, which is 15 pin. Yeah, 15 pin, and it is decoded and come out as a parallel data and go to the output LEDs. Okay, now we go to the circuit construction. Just look in the point of view of a IC HD12E and a RF transmitter. Okay, so if you see if this is this mark and see the left. Okay, there are 1 to 9 pins, and over here there are 10 to 18 pins. Totally here is 9, and here also it's 9. So just there are 8 programmable addressing pins. They used to be grounded, and there are 4 data pins. So this is sort of data pins 10, 11, 12, and 13. This are data pins. Just and here from RF transmitter is grounded, and from other side of the pins are used to be connected to the ground, and here it is connected to the data pins. Okay, then there is a oscillator pins 16 and 15, where the resistance 750 kilo ohm is connected between 16 and 15 in order to enable the oscillator. And there is a data output 17 pin, where when the input is given, which is 4-bit parallel data, the encode will happen and convert to a serial data and come out from the 17 pin. So this is a 17 pin where serial data come up. This is connected to the data. So VCC is here, where 5 to 12 volt is given. VCC means we need to give the power supply. So 5 to 12 volt is given to the VCC. Okay, and as an antenna, where it's connected to the antenna pin. Then that's it about the transmitter. Then we come to the receiver. A receiver is seen in the point of view of IC HD12D and RF receiver. Here also here is the 9 pins, under the here side is 9 pins, and those 9 pins are used to be grounded. It's 8 program addressing pins. 4 data pins is the 10, 11, 12, and 13, which is the 4 data pins, where it is used to indicates the output. Okay, and the LEDs is connected, and those things are grounded here, and our receiver is grounded, where this grounded pins used to be grounded. There is a valid transmission LED. This is very important because this LED used to indicates whether the transmitter is occurring or not. Okay, so it is a valid transmission LED pin, and here also there is a 16 and 15 pin where the 33 kilohertz resistance is connected in order to enable the oscillator. So in this VT pin, 17 pin is connected to the valid transmission pin, and in the same pin and the VCC is connected to the power supply, which is 5 to 12 volt we can given, and antenna is connected to the antenna pin. So whatever I said before, there used to be here. I you please listen. The circuit is divided into transmitter and receiver section. The transmitter section consists of an RF transmitter, HD12E encoder IC, and 4 push buttons. The receiver section consists of RF receiver, HD12D decoder IC and 4 LEDs, and extra LED is connected to the VT valid transmission pin of the decoder IC. This is used to indicate a successful transmission of data. A 750 kilo ohm resistor is connected between oscillator terminals of encoder IC. This is enabled the oscillator. Similarly, a 33 kilo ohm resistor is connected between the oscillator pin of decoder IC. Next is about working. Well, I tell about the working with the help of the circuit diagram itself. So only you can able to understand very easily. So I hope you guys are very familiar with the circuit construction. Now we go for working. Okay. When I giving input using the push buttons, there are 4 push buttons. When I give the input, those inputs are the go to this IC HD12E as a parallel data. Okay, those parallel data get inside IC using the pin 10, 11, 12, and 13. That parallel data used to be encoded and come out as a serial data from the D out something pin. That serial data get to the data. That serial data is sent to the antenna and it is transmitted using ASK modulation. With the principle of ASK modulation, the data is used to be transmitted. Those transmitted data it come to the receiver side. Okay, then those data, those serial data are demulated, and those serial data come to the pin number 14, data input 14 pin, and those serial data are what will happen? Decode will happen. Okay, after decoding, those serial data is again converted as a parallel data. Those parallel data are sent to the respective outputs, which is I connected the LEDs as output indicator, and there is a valid transmission LED, which is indicates whether the transmission occurring or not. It used to be blink whenever the data is coming. It used to be blink whether it is telling the data is coming. It used to be blink. So if you see the working, the HD12E encoder IC converts the 4-bit data from the 4 data pins that are connected to buttons into serial data. The serial data is sent to RF transmitter. RF transmitter transmits this serial data using radio signals. At the receiver side, the RF receiver receives the serial data. The serial data is sent to HD12D decoder IC, which converts into 4-bit parallel data. The parallel the 4 data pins of a decoder are connected to LEDs. According to the buttons push, the LEDs can be turned on or off. So I tell the working in the using of block diagram, so everyone can able to understand very easily about the working. When I give the input, okay, the input will be go as a 4-bit parallel data. Those 4-bit parallel data are go inside a encoding IC, which is called IC HD12E. Those encoder IC is converted into a 4-bit serial data. Those serial data sent to the RF transmitter, which is 4 to 3 megahertz frequency band. Those 4-bit serial data is sent to RF transmitter antenna. With ASK modulation, it used to be sent. They are sent to the RF receiver antenna. Those serial 4-bit serial data is sent to RF receiver, and it's a 4 to 3 megahertz. 4-bit serial data is sent to decoding. IC HD12D, it will decode and it come out as a, again it come out as a 4-bit parallel data, which is indicating the output LEDs. Features of RF module. Receiver frequency 433 MHz. Receiver typical frequency 105 decibel. Receiver supply current 3.5 milliampere. Lower power consumption. Receiver operating voltage 5 volt. The transmitter frequency range 433 MHz. Transmitter supply voltage 3 volt to 6 volt. Transmitter output power 4 volt to 12 volt. Specification module. Okay. Range in open space. It is about 100 meters given. Okay, we can give 100 meters, 200 meters. This is based on the frequency band. RX receiver frequency 433 MHz. RX typical sensitivity 105 dBm. RX supply current 3.5 milliampere. RX IF frequency 1 megahertz. RF operating voltage 5 volt. TX frequency range 4 to 3 megahertz, TX supply voltage 3 volt to 6 volt, TX output power 4 to 1 dB. So now we go for application of an RF module. As RF module doesn't require line of sight communication, the transmitter and receiver can be isolated over a distance and data can be transmitted successfully. The wireless transmitter and receiver can be used in car door and garage door controllers. They can also be used in home automation system. Patient health monitoring system with location details by GPS over GSM. Voice control home application also be used using the RF module. Now I will say some real-time example, which is we can see every day. You having the car, okay? You used to see the car key. It used to be like this. If you see the car key, there is a open car unlock and a lock. Okay, lock, unlock, and a back door to open and close. It used to be car key. But if you press the car key, the car is open. Okay, that's fine. It is only about what is it, on 10 meters or 12 meters range only. We can able to operate the car. Okay, only the 10 meters or the 15 meters, maybe sometimes 6 meters. We can able to operate the car to close or unlock like that. If you stand there in 1 kilometer away from your car, if you press the car key button, the car won't open. Why? Because the frequency range between the car key and your car door is a particular fix, which is somehow 130 kilohertz, some hertz like that. Only that frequency range only the operation will is happening. Okay, consider your car key as a transmitter, or your car is a receiver. Okay, once you are giving the signal as open the door, car is opening only in that particular range of band only. Okay, beyond that, nothing will happen. Well, you can take in a home application, home automation, where you can see this is like a transmitter and a receiver. Okay, remote is like a remote control. With one remote control, you can able to turn on the fan, turn on the light. You can operate the switchboard, everything with remote control. Nowadays, you can see, Alexa, right? If you say to Alexa, Alexa, turn on the light like that, Alexa will say okay and turn on the light. Everything based on this RF technology only. After 10 years, see every house used to be like a home automation only. Like if you're using a car, no, every house used to be like this. Okay, next we go for advantage and disadvantage of RF module. Advantage: highly portable, ideal for tour groups, easy to install, low installation cost, can cover large seating areas, several channels available for multiple systems installed in as well as for language translation and audio description for a blind. Suitable for indoors and outdoors. Okay. Disadvantage: required a receiver for everyone. Both headphones and neck loops must be available at a public facilities as coupling option. Facility owner need to maintain clean and colored receiver and keep receiver batteries charged. Radio interfacing from other services is possible. Feature scope: vital monitoring, remote control, small range wireless network, wireless home security system, wireless data transmission, digital home automation such as remote light switch, uh, remote control for various type of household application and electronics budget, mobile web service for elder monitoring people, elderly people monitor. Okay, you are seeing here inbuilt RF module. Okay, and this is one of my friends. Okay, he bought from market. He sent it to me about this. Actually, this is available in the market, but this is manufactured by a company where everything is inbuilt. See, the chip, IC chip is inbuilt. Here we can give the input data, transfer receiver is that everything is inbuilt. If you install this thing to anywhere in any places, and you can operate that thing. So you can able to design the RF module in the breadboard. Okay, I used to tell about transmitter receiver, how it is controlling. Everything could occur in a breadboard. If you are beginner, just write in a breadboard with the help of a DC supply, breadboard, IC chips, everything is available. So just write in a breadboard, and it will be very interesting too. Simulation using Protas 8 protocol, professional software. Sorry. Uh, well, you can use the hardware simulation, but using this simulation is very amazing and easy. You see here, whatever said before, you can able to buy hardware, but no problem. But this thing, which is software, where you can able to assemble like a simulation, and we can check. We can give the data where you can see the LEDs are blinking. Only it is like a software simulation. For beginners, I would like to say for my juniors that if you're a beginner, before go to the hardware, big hardware like that, before go to that, just try this kind of simulation. So this about 300 MB like that. Just download the simulation apps and just try it out. This will be very interesting. You can find a lot of components. Everything will be here. Everything is available. Just download and try it out. Then you go for a breadboard and go for a real hardware. This one I made it. This is one I used to assemble it. Everything I bought from the shop I used to assemble it. Don't worry, I will show the live demo right now, and it is going to be very interesting. If you can't able to understand what I said before, this live demo, if I show, you will understand. Okay, and the college given me a good chance to speak to my juniors and school students. So I would like to say something to them. Okay, this is not about RF module. Okay, this is about take like a senior giving advice to a junior. Things I must do in my first or second year, but I missed. Okay, after I come to the final year, I realize something else. Okay, I want to share those things to my juniors and school students. Don't ever waste your time. Okay, please guys, don't ever waste your time. Read the first point 10 times. Okay, just read. Don't ever waste your time. Don't ever waste your time 10 times. And please register in your brain. Other than downloading movies and series from Telegram or playing PUBG more than 2 hours, please use those data and time in your career. Like see YouTube videos related to your department, learn new things, understand how this concept is working, where it will be used, like that. Okay. Don't ever mug up your answer for exams. We are professional students now. Don't know more school studies, so focus on lecturers, learn and understand the concept. If you are not IT or CSE student, please study at least one programming language. You can learn by yourself from YouTube or a website like W3 School, Java T Point, okay, like that. If you are a CSE or IT student, work on software simulations. The software simulations like this, where don't need to buy the hardware at all. Okay, just download the software, just simulate and see. Then you can understand and very quickly. Okay, build some basic circuit, then simulate and see the output. Just learn something extra. Prepare for interview which you going to face in final year. Rounds like aptitude, group discussion, technical round, and HR. Career and passion is more important than your love life. First build your career, then find your love. But no love during the studies. Hope everyone will understand this last point. Okay, so this is about PP presentation. Now I'm going to show the hardware in the live demo. So if you can't able to understand what I said before in this PPT presentation, now I'm going to show the live hardware demo. It's going to be very interesting. Please everyone, just look on the demo. Okay, I stop the presentation and I come there in the live demo. Okay. Okay, now everyone could able to see my hardware. Well, everyone over here are used to be speaking Tamil, so I would like to explain this in Tamil. Okay. ஓகே, நான் தமிழே சொல்றேன். இதை நல்லா கேட்டுக்கோங்க. இது பாக்குறதுக்கு தான் ஏதோ டெர்மினேட்ல படத்துல வர அர்னால் மாதிரிலாம் இருக்கும். பட் ரொம்ப ஈஸி தான். ஒன்றும் பெரிய கான்செப்டா ஒன்றும் இல்லை. இப்போ நீங்க பாத்தீங்கன்னா நான் வந்து இன்புட் கொடுப்பேன். சரிங்களா? இன்புட் கொடுத்த உடனே அது இன்புட்ல வந்து 4 பிட் பேரல் டேட்டாஸா போவோம். போயிட்டு நம்ம இங்க பாருங்க, இது பேரு ICHT12E சொல்லுவாங்க. இது வந்து என்கோட் பண்ணும். ஸோ இன்புட் டேட்டாஸ்லாம் இங்க வந்து 4 பிட் பேரல் டேட்டாஸ் அனுப்புறேன். அது இங்க வந்து என்கோட் பண்ணுது. சரியா? என்கோட் பண்ண அப்புறம் அது வந்து 4 பிட் சீரியல் டேட்டாஸா வெளியில வருது. வெளியில வந்த அப்புறம் நம்ம வந்து டிரான்ஸ்மிட்டருக்கு போகுது. இதான் டிரான்ஸ்மிட்டர். நம்ம டிரான்ஸ்மிட்டருக்கு போகுது. டிரான்ஸ்மிட்டர் என்ன பண்ணணும்னா அந்த சீரியல் டேட்டாஸை இங்க பாருங்க, இதை நான் ஆண்டனா வயரா மாட்டிருக்கேன், இப்போ மன்னிச்சுக்கோங்க. ஆண்டனாவில் அனுப்போம். அது ஆண்டனா வந்து அனுப்பும் பொழுது ஆண்டனா வந்து ஏஎஸ்கே மாடுலேஷன் டெக்னிக்ல இது வந்து சீரியல் டேட்டாஸை அனுப்பும். அந்த சீரியல் டேட்டாஸ் நம்ம ரிசீவருக்கு போவோம். எப்படின்னா ஆண்டனாவிலே போவோம், வருமா? வந்த உடனே நம்ம ரிசீவருக்கு இதே எடுத்துக்கோம். அதே டிமாடுலேட் பண்ணி அந்த டேட்டாஸை சீரியல் டேட்டாஸ் தான் நம்ம இங்க போவோம், டீகோட் ஐசிக்கு போவோம். ICHT12D இது பேரு. இது வந்து நம்ம டீகோட் ப்ராசஸ் பண்ணோம். அந்த சீரியல் டேட்டாஸை டீகோட் பண்ணி திரும்ப பேரல் டேட்டாஸை நம்ம எல்இடிக்கு வரும். ஓகேங்களா? இப்படி பாருங்க, நான் வந்து இன்புட் தரேன். ஏற்கனவே பட்டன் இல்லை, நான் உடைச்சிட்டேன் நேற்று, அதனால நான் வயரே வச்சு பண்றேன். பாருங்க. ஸோ நான் ஒரு இன்புட் தரேன், ஒரு கிரீன் லைட் எரியுது. இப்போ நான் வந்து செகண்ட் இன்புட் தரேன். சாரி, பாருங்க, ரெட் லைட். தேர்ட் இன்புட் தரேன், ப்ளூ லைட். அண்ட் கடைசியாக இன்புட் தரேன். ஸோ இது நீங்க ஹோம் ஆட்டோமேஷன் நீங்க எக்ஸாம்பிள் எடுத்துக்கிட்டீங்கன்னா, இப்போ இப்போ எக்ஸாம்பிள் சொல்றேன். இது வந்து ஃபேன் எடுத்துக்கோங்க, இல்ல லைட், 2 லைட்னு எடுத்துக்கோங்க. இது வந்து கிச்சன்ல இருக்க ஒரு ஃபேன் எடுத்துக்கோங்க, இல்ல லைட்னு எடுத்துக்கோங்க. இப்போ நான் வந்து இங்க ரிமோட் கண்ட்ரோல் நான் வந்து கண்ட்ரோல் பண்றேன். இப்போ பாருங்க, நான் கிச்சன்ல இருக்க லைட்டை கண்ட்ரோல் பண்ணா அழுத்தின உடனே இது கிச்சனுக்கு லைட்டை அழுத்தம். அப்போ ஃபேன், ஹாலுக்கு ஃபேன் நான் ஆன் பண்ண போறேன்னா ஆன் பண்ணலாம். அந்த மாதிரி அட் சேம் டைம் அட் டைம் எல்லாமே ஆன் பண்ணி வச்சுக்கலாம், ஒன்றும் பிரச்சனை இல்லை. புரியுதா? ஸோ அவ்வளோதான், சின்ன மேட்டர் தான். ஓகே, ஐ திங்க் I finished almost everything. So this is how my RF module is like. Thank you.
I thank you, Mr. Farooq Junaid, on behalf of our management and our participants for spending your time and sharing your knowledge with us. I would like to thank every participant for attending this session and cooperating with us. I hope you have gotten a clear vision of whatever has been taught today. Once again, thank you very much. Dear participants, the feedback form is posted in the chat box. Kindly go through it and fill it up. Thank you.